All right, today we're talking about solving systems of inequalities by graphing. All right, so what exactly is a system of linear inequalities? Well, quite simply, it's two or more related inequalities. Specifically today, being related means that we're going to put them on the same graph. All right, what is the solution to a system of inequalities? Well, it's any and all points specifically XY coordinate points that satisfy both inequalities. And I say both. It could be all three, all four, all five, however many you got, but they satisfies all the inequalities in the system. For a graph, we're going to be looking at a shaded area as our solution. All right, so first let's look at how we would determine algebraically if a set of coordinates is a solution to a system. All right, well, how do we do that? Well, honestly, we plug it in. All right, so is 0, 0 a solution to this system? Well, let's plug it in. All right, so y is less than negative x plus 2. Well, we're looking at 0 for y is less than negative 0 for x plus 2. Well, negative 0, no such thing, so just 0. Plus 2 is 2. This is 0. Hey, 0 is less than 2. Yep, that works. So it is the solution to the first one. What about the second one? So 0 is greater than or equal to 2 times 0 plus 5. Well, 2 times 0 is 0, and 0 plus 5 is 5. 0 is greater than or equal to 5? No. All right, this is not a solution. Nope. All right, so let's do the next one. 1, 5. So we're going to plug in 1 everywhere we see x and 5 everywhere we see y. So doing the first one, 5 is less than negative 1 plus 2. 5 is less than negative 1 plus 2 is positive 1. 5 is less than 1? No. All right, we don't even need to do the second one. You can if you just want to be thorough, but if this was not a solution to our very first equation in our system, it doesn't matter if it's a solution to the second one. All right, next, 10, negative 10. So we're going to plug in 10 everywhere we see x, plug in negative 10 everywhere we see y. So negative 10 is less than negative 10 plus 2. Negative 10 is less than negative 10 plus 2 is negative 8. Negative 10 is less than negative 8? Yeah. Hot dog, we got one. All right, let's see here. Next one, negative 10. How about 10? There we go. Is greater than or equal to 2 times 10. This is a parentheses. There we go. Plus 5. So negative 10 is greater than or equal to 20 plus 5. Negative 10 is greater than or equal to 25? No. All right, that one's not a solution either. Nope. All right, last one. Let's plug this guy in. Negative 4 for x, negative 3 for y. So negative 3 is less than negative 4 plus 2. So negative 3 is less than a negative 4 is a positive 4 plus 2. Negative 3 is less than 6. Yep, that works. All right, let's plug it into the second one. Negative 3 is greater than or equal to 2 times negative 4 plus 5. So negative 3 is greater than or equal to negative 8 plus 5. So -3 is greater than or equal to -3. Hey, that also works. All right, so yes, this point is a solution to this system. All right, so how do we solve it if we don't want to go through this process and test every single point known to man? Well, we put it on a graph. All right, so steps to solving. Solve for y in each inequality. You need to put it in that y equals mx plus b form, the slope-intercept form. I know we have taught with regular equations that you can find the x-intercept, the y-intercept, and graph it from there. That's fine for getting a line. When you're doing inequalities, though, you have more to worry about than just getting the line in the right spot. You also have to worry about dashed or solid. And the big one here is the shading, all right? And the shading is the real reason why we don't want to just find x-intercept, y-intercept from standard form and go on, because sometimes you end up dividing by a negative and that operator in the middle, that greater than, less than, flips over. So always put it in slope-intercept, y equals mx plus b form first before graphing. All right, our first one is already solved for this. Y is less than or equal to -5x plus 2. So let's graph this guy. Starting at our y-intercept, which is 2, our slope is -5, so I'm going to go down 5, 1, 2, 3, 4, 5, and right 1. Go back to my y-intercept, I'm going to go up 5, 1, 2, 3, 4, 5, and left 1. Back to this point, 1, 2, 3, 4, 5, and down 1, and then we can draw a line. Let me grab a nice line tool here. And we'll draw ourselves a line. There we go. So now we have our first line. Now let's get our let's do our shading, shall we? Our shading says y is less than or equal to. So I want all the y's that are less than this line. So let's go back. Let's look at our y-intercept. Where are the y's that are less than 2? Well, I've got 1 on this side and I've got 3 on this side. Well, 1 is less than 2. So that's the side I want to shade. All right, so everything on that side of my line is less than, and that's what I want to shade. All right, going back up, let's get a different color. I'm going to grab green here. All right, this says y is less than or equal to 3x. All right, and we can say 3x plus 0 just for emphasis, which means I'm going to be starting at my origin. All right, my slope is 3, so I'm going to go up 3, 1, 2, 3, and right 1, up 3, 1, 2, 3, and right 1, up 3, and right 1. Going back to my y-intercept, I'm going to go down 3, 1, 2, 3, and left 1, down 3, 1, 2, 3, and left 1, and I can keep going. All right, now I'm going to grab my handy dandy line tool again, and I'm going to draw my line. Make sure that I'm all lined up here. There we go. All right, now we're going to do our shading. And this says y is less than or equal to 3x. So looking at this, put your finger or your pen right there on the y-intercept. This is 0. Where are the y's that are less than 0? Well, above this, I've got 1. Below this, I've got -1. -1 is less than 0. So we're going to shade on the -1 side. All right, so where's my solution? Well, with just a system of linear equations, we were looking for a single point, right? We had an x and we're like, aha, that's my solution right there in the center. Well, for this, yeah, I've got a solution right here where they overlap. Let me get my purple pen so you can see right here. But more than just that overlaps. Do you see how our shading overlaps? So literally everything in here and these two lines is the solution. So all of this is the solution to my system. All right, let's graph another one. All right, 2x equals 5y I'll say this right here in a minute. 2x plus 5y is greater than or equal to 5. There we go. All right, we want to put this in slope-intercept form, so we're going to subtract 2x from both sides. So I have 5y is greater than or equal to negative 2x plus 5. All right, divide both sides by 5. Y is greater than or equal to negative 2/5 x plus 1. Let's do the other one while we're here. Minus 4x minus 4x. So 10y is less than or equal to negative 4x plus 40. Divide both sides by 10. So y is less than or equal to negative 4/10. Let's go ahead and reduce that to negative 2/5 x plus 4. All right, and then let's graph it. Starting with our first one, y equals negative 2/5 x plus 1. And my slope is negative 2/5, so down 2, 1, 2, all right, 5, 1, 2, 3, 4, 5, down 2, right 5. Go back to my y-intercept, and I can go up 2 and left 5, up 2 and left 5. I'm going to grab my handy dandy line tool here. Draw our line across. All right, then we're going to do our shading. And this one says y is greater than or equal to. Back to my y-intercept. Where are the y's that are greater than 1? Well, they're above it, right? So I would shade on this side. All right, next I have, and we're going to grab green for this, y is less than or equal to negative 2/5 x plus 4. So let's find 4. 1, 2, 3, 4. My slope is negative 2/5. Down 2 and right 5. Down 2 and right 5. Back to my y-intercept, up 2 and left 5. Up 2 and left 5. Grab my handy dandy line tool. And we'll draw a line. Oh, do you always notice that they're parallel? Maybe this is a no solution. All right, let's find out. So we've graphed both of our lines. Now let's talk about the shading for our second line, for our green one. And it says y is less than or equal to. So looking at our y-intercept, where are the y's that are less than 4? Well, this is 5 up here. This is 3 down here. 3 is less than 4, so I'm going to shade on this side. And I get everything there. All right, so where do we overlap? What are solutions? Well, everything in between them and both of our lines, because they're part of the overlap. So that's my solutions. All right, now if we wanted to test a point, how would we do that? So let's look at our first one. If I said, is 5, negative 3 a solution to this system? How would you know? Well, we learned how to do it algebraically, right? We could plug it in at the top algebraically into each equation and do all of that. But we've got a graph. There's a much faster way. So I simply find where 5, negative 3 is, right? So starting at my origin, 1, 2, 3, 4, 5, negative 3. 1, 2, 3, right there. Is that in my shaded area where both of my shades meet? No, so that's not a solution. What about over here? What if I said is negative 2, 3 a solution? Well, let's find out. Negative 2, 1, 2, 1, 2, 3. Yeah, that's well in my shaded area. That's a solution. All right, so when you actually have a graph of a system of inequalities and you're asked to check if something is a solution, it's really easy. Just plot that point on the graph and see if it meets the overlapping areas. All right, let's look at our back page. One smart notebook decides to flip over. All right, and really what I wanted you to see right here is D and E. You notice how D and E have 3 equations each. All right, don't panic. This is not any different than what we've been doing, right? I just got 3 instead of 2. So we're going to take it one piece at a time. First thing I'm going to do, though, is I'm going to convert D here into slope-intercept form. All right, so subtract x from both sides. So that gives me negative 4y is greater than or equal to negative x plus 8. Divide both sides by negative 4. Remember, when you're dividing by a negative, to flip that operator in the middle. So y then is less than or equal to negative 1 divided by negative 4. So that's going to be a positive 1/4 x minus 2. All right. So then we're going to graph these guys. Starting out with the first one, y is less than 3x plus 2. Start at our y-intercept, which is positive 2. My slope is 3, so up 3, right 1, up 3, right 1. Back to my vertex, my y-intercept, down 3, left 1, down 3, left 1, down 3, left 1, and so on. Then we can draw our line. But wait, did you see? This is just less than. It's not less than or equal to. So this needs to be a dashed line. So let's go through and make this guy dashed, shall we? Don't forget to watch out for that, guys. All right, next, let's grab our green. Let's graph our one we just did here. So this is negative 2. My slope is 1/4, so I'm going to go up 1 and right 4, up 1, right 4. Go back to my y-intercept, down 1, left 4, down 1, left 4, down 1, left 4, and that's as far as we can go. This is less than or equal to, so it will end up being a nice solid line. Guys, we're going to do the shading here in a minute because I want you to be able to see the lines. All right, let me grab a red pen here and we'll do our last one. Y is less than or equal to negative x plus 6. So let's do plus 6. 1, 2, 3, 4, 5, 6. My slope is negative 1, so I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. Oh, look, I've got a nice little triangle right here in the center. Let's see where our shading ends up. All right, so that's all my dots. And let's draw my line. All right, so let's start with the shading for this one. And notice it was less than or equal to, so I was right with the solid line. So less than or equal to, this is 6. Where are the y's that are less than 6? Well, they're down here. So my shading is going to be on this there. All right, let's go back to our green line, which is this one. Green line is less than or equal to. So where are the y's that are less than negative 2? Well, they're down here. All right, next, blue line. And we want less than this line. So where are the y's that are less than 2? Well, they're down here on this side, right? Okay, so where do they all three intercept? Do you see an area where we have all three? Let's grab my purple pen. Well, it's bordered by this line, this line, this dashed line, and then everything in the center here. All right, so any point in here in my purple area is a solution. When y'all are graphing these by yourself, if you're doing it on paper, I recommend using a pencil, shade lightly, and then you'll be able to see very easily where it's darkest, where they overlap. Alternatively, colored pencils, highlighters work really, really nicely. Any of the above, or you can do the 3 different colors like I've been doing if you're doing it with like Google Drawing or Cami. 3 different colors works well. All right, as always, guys, email me if you have any questions, and good luck with your homework.